Hello guys, this is TK, and today I figured out how to use the CAN function of the GD32 VF103. So here the most important thing is that when configuring the GPIO port, we need to leave the RX pin to floating. This is very important. Okay. Not here. This is UseArt, but it's same for CAN. Here, because we are using CAN 0. So according to the pinout, CAN 0 RX is pin PA11. So here we configure PA11 to input pull up. Yeah. So this line is very important. And because pin 2 TX is output, we set it to push and pull. So the logic is, first we enable the RCU clock for CAN 0 and GPIO-A, and then initialize the pin, and here we configure the CAN knob configuration. We have two parameters, the CAN parameter and CAN filter. We are not using the CAN filter now. And first we initialize the CAN 0 and then set all these settings. The important ones are these three. So the prescaler defines how the clock should be. So prescaler 3, I think it's 108 divided by 3 plus 1, so 108 divided by 4. That is, oh, my computer freezes. Okay, 108 divided by 4, it's 27. We are using 108, right? So to change clock, we need to change it here. And now we are using the 108 megahertz. So then it's 27 megahertz for the CAN clock. And then we assign time quanta to segment of 11 to segment 1 and 6 to segment 2. That's 17, and plus this one it's 18. 27 divided by 18, 1.5. Well, I'm not exactly sure how math works here. Maybe it's 108 divided by 3, 36, and divided by 18, that's 2. I don't know, but I figured out these numbers with the oscilloscope. Yeah. So firstly, and it freezes again. Come on. Okay. Firstly, I used the Arduino to output some CAN messages. Here we set it to 1 megahertz, and this is for the crystal oscillator on the module. So it's right here. It says 8 megahertz. So here we use 8 megahertz. And I use Arduino to output a signal on the CAN bus and see the width of the signal. So here it's the total width is 43 microseconds. And if we look at 1 bit, we can enlarge it. 1 bit here, then it is 1 megahertz. That's right. And then I used trial and error to generate the same signal using the GD32, and I then get these results. After that, we initialize the CAN function. If we are if we configure this pin wrong, then it won't initialize. I have stuck here for like 3 days, but now it works fine, which is great. And after initialization, we create a CAN message. Here we just use the standard frame with the ID CA, and data type is like frame type is data, and it's standard frame. We append one length of the message which says 00, and we can uncomment this line so that the value increases each loop. And then we send the message using the CAN message transmit. And here the mailbox, if everything works fine, the mailbox should return 0 because it puts the message into mailbox 0 and then send it, and then that's done. And when the second message arrives, the mailbox 0 is clear for handling it. And if it is equal to 3, then we have a problem because 3 means no mailbox here. So this thing, its value is 3. And let's upload it again. And here we should see, the signal changing here. And also on the Arduino side, I am running a script to listen to the message on the CAN bus. Let's run it again. Oops, something is wrong. So the time corner is still not quite correct. I'm just gonna pause here because I'm gonna try and narrow this thing. Yeah, but that's basically how it works.